Today we're going to go over the geometry unit review for Carlton, and I call it the Dudley kids, we call it the chapter 11 and 12 review with Carlton's name on the end. Alright, let's get going. We have to find the area of these shapes, the approximate area or the area. This one here we'll have to approximate. Let's go ahead and start with this one. We'll do things a little bit differently. I'm just going to make a couple of rectangles here. I can find a big rectangle, a little rectangle, and then a triangle. Well, if you count this, it's 1, 2, 3, 4 here, and 1, 2, 3, 4, 5, 6, 7, 8 going across. So if you multiply those numbers together, you get 32. This rectangle has 32 square units. This one down here, 1, 2, 3, 4, 5, 6, you got 6. And then up here, this one, of course, is 8 across the base, and it's too high. So if you multiply 8 times 2, you have 16. Well, 16 would be the area of that rectangle. We only have the triangles. We have to divide that by 2. 16 divided by 2 is 8. So if we add up these guys here, we have 8 plus 32 is 40, plus 6 more is 46. 8 plus 32 plus 6. Let's find the area of this. We got a half circle and a trapezoid. Let's do the trapezoid first. Here's the half trapezoid formula. 1/2 the height times base plus base. So let's just substitute this in. A half the height would be, well, half of 14 is 7. We multiply that by 20. This is the top base. And 32, the bottom base. That's really the same as 7 times 52. 7 times 50 would give me 350, and 7 times 2 would be 14, so this would be 364. So the area of this one would be 364 millimeters squared. So we're going to just leave that. We'll add that to the area of the half circle. The area of a half circle, we need pi r r. That's the area formula for area of a circle. And then we're going to have to divide that by 2 because we only have a half a circle. We don't have the radius, we only have the diameter. The diameter is this line that goes all the way across. So let's make a radius. The radius will always be half the diameter, so that's 10. So pi is 3.14 times the radius, so times 10 times 10. We have to divide that by 2. Well, that's really 314 when you multiply that on your calculator. It's 3.14 times 100. And we'll divide that by 2. Half of 300 would be 150 plus 7 more. That would be 157. So the area of this half circle then would be 157. So let's just take and add the 157 and we'll add the 364 together and we will get our area. So 157 plus 364. That's 521, and that is going to be millimeters squared. Let me just double check my math here. That would be a 1, this would be a 2, and 521 millimeters squared. Very good. Let's keep rolling. Number 3 here, it looks like we have a parallelogram and a trapezoid. Let's do the parallelogram first. These would be the bases of the parallelogram. We can see from these little marks here that they are the same. So this one down here is 10. Here's the area. Here's the formula for a parallelogram. It's just base times height equals the area. So the base is 10. So 10 times the height, which is 1.5. Well, 10 times 1.5, I could just move that decimal. You can put it into your calculator, but it's 15. So I've got 15 here. Let's find the area. Sorry about that. Let that focus. Here's the base times the height equals the area. Here's the 10 times 15. Let's go ahead and do the area of the trapezoid. Again, here's the trapezoid area. It's formula 1/2 height, base plus base. So half of the height, here's the height. The height is 1.5, so that's like $1.50. Half of that would be 0.75. And we can multiply that by the big base, which is 10, plus the small base down here, which is 7. So that's really the same as 0.75 times 17. And if you pop that in your calculator, you're going to get 12.75. 12.75. So now we have to add those two areas together. So we take the 12.75 and we add the 15, and that looks like 27.75 centimeters squared. Sure answer to that. All right, on this one here, this is another one of those ones where we really can't maybe determine the exact measurements because we haven't got any measurements, but we do have some boxes. They're very thin, but I think I can count them. 1, 2, 3, 4, 5, 6. Looks like 7 down and 2 across. So this would be 7 and 2. So this rectangle right here would be 14. Here's another one here. Looks like 6. 1, 2, 3, 4, 5, 6. So now we'd be up to 20. And then this one here, we'd have one whole one and then 2 halves. So this is 2. So it looks like 14 plus 6 plus 2 would be 22 units squared. All right, area and circumference of circles. The area, it says area down here too. I think it's on the next page, but we'll do them both right here. So the circumference, here's the formula. Diameter times pi. In this case, we don't have a diameter, so we'll make one. Diameter is the line that goes all the way across. It's the long word, diameter, and it's the long line. This is the radius, short word, short line from the center circle. So if I take the 7 times 3.14, that's going to be about 21, 22. I put that in, 3.14. Oops, I'll do it just the way it says. 7 times 3.14, 21.98. So circumference is 21.98. And that's just going to be meters. The area is pi r r, like a pirate. So that's going to be 3.14 times the radius times the radius. So now we can use that 3.5 times 3.5 times 3.5. Yep, there we go. 3.14 times 3.5 times 3.5. Put that in the calculator. 3.1. Sorry about that. 3.14 times 3.5 times 3.5. 38.465. 38.465, and that will be in meters squared. Okay, let's get the circumference and the area of this one too. This time we have the diameter, so again, d pi is our formula. Diameter times pi is around. D pi is around. It's like the pi is round, but d pi is around. Diameter times pi. All right, so let's take the diameter. 18 times 3.14. This is going to be about 56. 18 times 3 is 54. We got a little extra there. 18 times 3.14. 56, 52 equals 56.52, and that's going to be inches. And let's do the area. Here's our formula. Pi r. I know it's stupid, but hopefully you'll remember it. Well, we don't have a radius, so let's make one. It's just going to be half of the diameter, which is 9. So 3.14 times 9 times 9. That's going to be 3 times 81. That's going to be about 250. 3.14 times 9 times 9. 254.34. 254.34. And that will be in inches squared, because that's an area. All right, we've got a couple other circles on this next page. Okay, let's do the circumference here. Again, it's d d pi. The diameter is 6, so it'll just be 6 times 3.14. It's going to be about 18, 19. 6 times 3.14. Is that 18.84? And that's going to be inches. Those two little marks mean inches. And area is pi r. Pi r r. We have to make a radius. If the diameter is 6, the radius is 3. So 3.14 times 3 times 3. It's a horrible looking 3. So let's put that in. 3.14 times 3 times 3. 28.26. 28.26, and that'll be in inches squared. All right, circumference will be d pi again, and the diameter is going to be 20. So 20 times 3.14, that's going to be about 60 some. 20 times 3.14, 62.8. And that's in meters. The area again, pi r r. Well, here's my radius here of 10. So that will be 3.14 times 10 times 10. Well, that's really like 3.14 times 100. And I can just move the decimal twice, so that's going to be 300. That's a horrible 3. 314 meters squared. Okie dokie. I'm going to do 2 more problems on this one, and then I will do I'm going to do part 2. I'm going to do this in 2 videos because I'm having some problems getting it to upload correctly. Well, finding the volume of rectangular prisms, you can do it this way, 11 times 5 times 6. This is the way I was taught when I was a kid. This is really 55 times 6, which is really 330 centimeters cubed. We're trying to get you to think nowadays about big base times the height. So this would be the base. In other words, you find the area of one of them. We got 5 times 6. That is 30. See, that's already got 2 of the dimensions in it, the 5 and the 6, and we just multiply that by the height, which would be 11 in this case, and that's still 330 centimeters cubed. So you're looking at it both ways. I'll do this one. Base here would be 4 times 4, right? We'll do this, the big base times height. Well, the big base would be 16 times the height, which is 8. That's right here. And that's 128. And that's going to be units cubed. We don't have a label, so we'll just call them units cubed. Right. I think I'll go ahead and do the triangular prisms as well here. We're still less than 15 minutes. Triangular prisms. Well, once again, you can use that same formula that you used up here. You just multiply the length times the height times the width. 8 times 3 times 12. This is 24 times 12. I think it's 288. 24 times 12. Yep, 288. But if I left it like that, what I would have done is found the volume of a rectangular prism. And this is not a rectangular prism. You know, this is a triangular prism. So I have to divide that by 2, which is 144 centimeters cubed. Another way to do it is to just find the area of the base like we did before. That's 3 times 8. I'll just do it here. The base times height equals the volume. The area of the base is 8 times 3 is 24 divided by 2 because it's a triangle is 12 times the height, which is 144. So you can get the same answer, just a different way of thinking about it. I'll do the base times the height one here. I like it. It's what we're trying to get you to think about. We'll find the area of this triangle then. Well, that's going to be 16 times 12 divided by 2, right? So 16 times 12 equals 192 divided by 2 should be 96. So their base here is 96, and we just multiply with the height. This is the height right here, 10. This measurement here is not the height, that's the measure of that side. So that's 960 centimeters cubed. All right, in this target, we're finding the surface area of a rectangular prism. So surface area is, you can think about it as finding the area of all 6 sides. So I'll just put down 6 lines here because there's 6 different sides. We'll just find the area of all 6 sides. Let's start over here on the end. We've got a 1, 2, 3 times 1, 2, 3. So 3 times 3, those are going to be 2 sides of 9. And I'm just going to cross this off because I'm already done with that side. And the other end, which would be over here. All right, now let's do the top. 1, 2, 3, 4. So this would be 4 times 1, 2, 3. 4 times 3 would give me 12. 12 in the top, 12 in the bottom. I'll cross it off because I'm done. Now we just have to do the front and the back. This is 1, 2, 3, 4, just like we had up here on top, and 1, 2, 3 down here. The front and the back will be 12. Now we're just going to add these numbers up. Well, these are 24, these two together. These two are 24, and these are 18. So really, we can add 24 plus 24, which is 48. And then we'll add the 18 to that, and that is 66 units squared. Another way you can do this is to take the numbers, like on this problem here. You can take the numbers 6, 2, and 3, and I call it the speech bubble method. You do 6 times 2, that's 12, and there's 2 of them. There's 2 sides that are 12. You can do 6 times 3, which is 18 and 18. And you can go backwards, kind of complete the speech bubble. You have 3 times 2, which is 6 and 6, and you can add all of these numbers up. These two numbers together equal 30. These two numbers together equal 30, so 30 plus 30 is 60. These two equal 12, so you have a total of 72. That would be centimeters squared. So you can draw them and cross off the sides and use the 6 lines. You can use a speech bubble. Sometimes they give you a net. This looks confusing, but it's really not. Multiply these numbers together. Here's your 18. That's the top, and of course the bottom is also going to be 18. This side here, it's 2 here, and it's 6 here, so that's a 12, and of course this is a 12. And then over here, this side here is 3, and it's 2 high. We can get that measurement from right here. It says 2. So this is 6, and this is 6. So you have the same numbers as I had up top, and when you add them up, you're still going to get 72 centimeters squared. Triangular prisms, they're a little different, a little bit harder, and I think the best way to do it is just draw the various shapes that you need to find. You need to find 2 triangles. These will be our triangles, the front triangle and the back triangle, and then we've got this piece here. It's kind of this angular piece, that kind of goes up, and the top of the door stop, if you want to think about that. And then you can also think about you have the back, which would be kind of like this, or this end side, and then you have the bottom like this. So these are the 3 sides, and they don't have to be perfectly drawn. I try to kind of draw them in relationship to where they are, and the next time I'll even make it simpler for you so you understand. But the areas of the triangles, well, this triangle is 3 times 4, so this is 3 times 4. So 3 times 4 is 12, and then you have to divide that by 2 because it's a triangle. So this is 6, and of course the other triangle is 6. So those 2 triangles together, we've got 12. This will just be our little tally chart over here. We'll add all these sides together. Well, the top is 7 inches this way, and it's 5 inches this way. this drawing is not proportional. Well, that would be 35. 7 times 5 is 35, so I can put that over there to add in. The bottom is still 7, but it's 4 inches, so that's going to be 7 times 8. That's 28 I can add in. And then we've got this side over here, and again, the end, we'll call it the end. Call this the top, and this is the bottom, I guess you could call them, if you want to give them some labels. But the end is going to be 7, and it's 3. So that's going to be 21. So you've got 21. You got a lot of multiples of 7 there. But you can just add all these guys up. Just do it in a calculator. Do it real quickly here. So we've got the 2 triangles are 12, plus the rectangle that's 35, plus a rectangle that's 28, plus a rectangle that's 21. That's a total of 96. I'm just going to double check that. 2 plus 5 would be 7. 7 plus 8 is 15, and 1 makes 16. Here's my trade. We have 2, 5, and 4 more make 96. Yep, 96 inches squared. I like to double check my work. So then on this triangle here, we'll go ahead and I won't be as fancy this time, just draw a couple of triangles here. And then I'm just going to draw some rectangles. This one here, we'll call this one here, call it the front. And we'll draw another one, just call it the back. Draw one over here, call it the end. So let's do the triangles first, so you can see a little bit better. The triangles, well, the triangle has a base of 6 and a height of 4. So 4 times 6 is 24, but when we divide them by 2, each triangle will be 12. So there is 24 altogether for the triangles. Okay, so let's see the front. The front is 6 on the bottom and 8 on the side, so that's 48. That front. Think about the back. Back's length is going to be 5, that's that measure, so that's going to be 40. 8 times 5 is 40. And then the end over here, this measure is going to be 3, and it's still 8 tall, so that's 24. So we can add those on there. We have 40 and 24. Let's just double check. We have 2 triangles, they make 24. We have a 48 rectangle, we have a 40 and a 24. I'm thinking 136, but that's a guess. 24 plus 48 plus 40 plus 24, 136 centimeters squared. I'm not going to double check that one because I kind of did it as I was adding it in my head as I went, and it matched my estimate. All right, good luck. Thanks for listening.